Okay, so let's start with the visualization with Matplotlib. Now, Matplotlib is a library available with Python, and it is very useful. It is used basically for visualization purpose. That means we can create various kinds of plots and graphs, etc., for the purpose of analyzing the data without creating any table, etc. So that is the purpose of Matplotlib, and it is being used extensively for any kind of a data visualization. So let's see some details about it. Now, Matplotlib is a plotting library for the Python programming language, and its numerical mathematics extension is NumPy. It provides an object-oriented API for embedding plots into applications using general-purpose GUI, that is graphic user interface toolkits like Tinker. Now, what is Python Matplotlib? Matplotlib.pie plot is a plotting library used for 2D graphics in Python programming language. It can be used in Python script shell, web application servers, and other graphical user interface toolkits. There are several toolkits which are available that extend Python Matplotlib functionality. Some of them are separate downloads, others can be shipped with the Matplotlib source code itself, but have external dependencies. Now some of them are like basemap. It's a map plotting toolkit with various map of projections, coastlines, and political boundaries. All of you must have seen, variety of maps in soft copies and maybe in the hard copies also, sometimes printed, sometimes in the you also see in some of the advertisements. So various forms these base maps are available. Then Cartopy, it is a mapping library featuring object-oriented map projection definitions and arbitrary point line, polygon, and image transformation capabilities. Excel tools. Matplotlib provides utilities for exchanging data with Microsoft Excel also, right? Then MPLOT 3D, it is used for 3D plots. Three-dimensional plotting or graphs are becoming quite popular now, and lots of people have started using it, and lots of software are also getting available now. So NADGrid, and the next is NADGrid. It is an interface to the NADGrid library for irregular gridding of the spaced data. So these are some of the unique features of Matplotlib. Now, types of plots. There are various plots, and these are of course the standard types which I think everybody must have seen or worked or created in his career. So like bar graph, histogram, scatter plot, area plot, pie plot, and like that so many very basic plots which you must have seen or created. But there are some special types of graphs which are available with the Matplotlib. So let's see very basic codes in Python Matplot. Now, for making any graph, you need to learn Python because it is associated with the Python. So you can, and the codes are very simple, very small. So you need not stress too much, but definitely you have to learn the coding. So from Matplotlib, import PyPlot as PLT, plotting to our canvas, whatever canvas or frame that you have made it. Then plt.plot 1, 2, 3, that is in one array, and then 4, 5, 1 is another array. Then showing what we plotted. Now you are going to show. Then plt show, and simply you can see that a line graph is now available to you on your screen as it is shown. So with 3 lines of code you can generate a basic graph using Python Matplotlib. Let's see how can we add title also, because you see it's a bare line graph or any graph for that matter is not very meaningful. So it is always better to have the title or whatever the information extra you can provide. So it may be labels or your graph or created in the Python Matplotlib library to bring in more meaning to this. Now, and how to do that? From Matplotlib, import PyPlot as PLT, x is equal to 5, 2, 7, again some random numbers. Then y is equal to 2, 16, 4, and then again PLT plot x, y, because x and y, these are the two variables in which these two arrays are stored. Then PLT title, info or whatever name you want to give, you can give it. Then PLT y label, y axis, and PLT x label, x axis. Again simple. Then PLT show. So you can simply plot it, and you will see that two different lines are plotted on your screen. Then many styling techniques are available to create better graphs. You can change the width or color of a particular line, or what if you want to have some grid lines also. For these options you need styling. So let's see how to add style in a graph using Python Matplotlib. First you need to import the style package from the Python Matplotlib library, and then you use styling functions as shown in the code. Now how do we do that? From Matplotlib import PyPlot as usual as PLT, then from Matplotlib import style, that is something new. Then style.use ggplot. Now this is the plot which is going to give you this kind of a plot which you are seeing on your screen at the right side. So x again is 5, 8, 10, that is again another random number. Then y is equal to 12, 16 and comma 6. Then x2, another two variable, that x2 is 6, 9, because there are two lines, red and green, that you can see on your screen. So there are two variables there, that is why we have two, because x and y for say one line, and then x2 and y2 for another line, another set of line. Then plt.plot x comma y g, that is green line, label is equal to line 1 and line width is 5. Why we have kept it as 5? So that it can emerge out very clearly. You can keep the line width maybe 1, 2, 3, whatever. Depending on that, the line width or thickness of the line will be there. Similarly, now next is plt.plot x2 y2. Now color is label is equal to line 2 and line width is again 5, same width. Then title, plt title epic info, that means whatever title you want to give, again here we have given as epic info. Then plt y label, y axis, plt x label, x axis. Then plt legend, that means you are seeing on the right top side, that is green and red or orange, whatever color you can make it. Then plt.legend is there, and plt grid, you can see a grid also in the background, that also has created. And then plt grid true, that is color is equal to k, right? So when you plot that graph plt.show, you can see a graph coming like this as it is shown on your screen. So that is how you can make different types of graph. Now the next is bar graph. Now bar graph is very commonly used in any say analysis. You will see that bar graph is very common. So first let's understand why do we need a bar graph. Bar graph uses bars to compare data among different categories. It is well suited when you want to measure the changes over a period of time. It can be represented horizontally or vertically. Also, the important thing to keep in mind is that longer the bar, greater is the value. Now let's practically implement it using Python Matplotlib. So you can see a view of that is available on your screen. So you can see that how these bar graphs are created. Let us see how we are going to create it. So these are the codes for that. Again from Matplotlib, import PyPlot as PLT, then plt.bar 0.25, 1.25, 2.25, 3.25, 4.25. This is in one array. Then 50, 40, 70, 80 and 20. Now the label is BMW. And then width is 0.5. Then next is plt bar 0.75, 1.75, 2.75, 3.75, 4.75, and then 80, 20, 20, 50, 60. These are again two different arrays which are stored in this plt bar, and two different types of bars which are going to be there. Then there is another car like Audi. Color is red, width is equal to 0.5. So same width and different colors are given so that you can easily distinguish the two. Plt legend, that of course automatically it will create. Plt.x label, that is days, which you can see on the x-axis, and plt.y label, that is distance, kilometers. So in that particular day, one day or second day or third day or fourth day or fifth day, how many kilometers it has run, that is what the purpose of depicting this kind of a plot. Then title of the plot is information. and then PLT dot show. So you can clearly see in this that how on different days how many kilometers of the different cars, whether it is BMW or Audi, has gone in for. So in the above plot there is a comparison between the distance covered by two cars, that is BMW and Audi, over a period of 5 days, right? So this is how, this is a very simple example, but definitely you can have a complicated one also, but the graph becomes very simple. Then histogram. Now difference between a bar graph and a histogram, which I think looks quite similar, but then histograms are used to show a distribution, whereas a bar chart is used to compare. That is the basic difference between the histogram and the bar graph. Histograms are useful when you have a arrays or a very long list, right? So that is the basic difference, and that you must keep in mind whenever you want to create a bar type of a chart or graph. You must keep that whether you want bar chart or you want a histogram. Let's consider an example where I have to plot the age of a population with respect to bin. Now bin refers to the range of values that are divided into series of intervals. Bins are usually created of the same size. In the below code that you are going to see, bins are created in the interval of 10, which means the first bin contains elements from 0 to 9, then 10 to 19, and so on up to 100, right? So that is how we can create the graph for this. So for making that graph, import Matplotlib Pie Plot as PLT. Population age is equal to like this, 22, 55, whatever numbers are mentioned here. Then bins are 0, 10, 20, 30, 40 up to 100. Then PLT.histogram we are going to create. Population age, that is mentioned there. Then hist type is bar, and R width is equal to 0.8. Then PLT X label age groups, and PLT Y label number of people, and PLT dot title histogram. So PLT show. So you can, once you execute this code, you will see that you will get this type of a histogram on this. So you can see that this graph shows you at x-axis it is age group, and y-axis it is number of people. Title is histogram, right? So you can see that all this code that we have mentioned here, all this has taken care of, and now we are getting this kind of a graph. So as you can see in the above plot, we got age groups with respect to the bins. Our biggest age group is between 40 and 50. That is quite visible. It's quite informative, because just by creating a very small graph, writing just 4-5 line code, you are getting the what you want to know. So that is the purpose of these graphs, and that is why Matplotlib becomes very useful in making these kinds of graphs. Now the next is scatter plot. Scatter plot is again very useful, and it is usually when you need it for in order to compare variables. For example, how much one variable is affected by another variable, to build a relation out of it. The data is displayed as a collection of points, each having a value of one variable which determines the position on the horizontal axis, and the value of other variable determines the position on the vertical axis, right? So again the code is simple. Import multiple Matplotlib Pie Plot as PLT. X again has values like 1, 1.5, 2, 2.5, 3, 3.5, like that. Then Y as 7.5, 8, 8.5, 9, 9.5, and like that up to 10.5. Similarly you have X1, Y1 also. Then PLT scatter, these are all data points, and then PLT scatter XY label is equal to high volume, low saving color. Color is equal to R, red. That means people who are earning high, they are saving less. This is just a comparison, just a data. PLT scatter X1, Y1 label, low income, high saving, and that is shown with the color B, blue. So PLT X label saving into 100, and PLT Y label income into 1000, right? This is again, and random figures has been taken. So PLT title is equal to scatter plot, and PLT legend, that is given on the right side top. You can see whatever we wanted, we have mentioned it there. And then PLT dot show, that is you execute the code and you will get this kind of a graph. So as you can see in the above graph, there are two scatter plots based on the inputs specified in the above code, the code that we have seen. The data is displayed as a collection of points having high income, low salary, and low income, high salary. This is how you can, say salary or saving, whatever name you want to give, you can give it, and you can see the graph will be available to you. Now another very useful and very commonly used plot is the area plot. Now area plots are pretty much similar to the line plot. They are also known as stack plots. These plots can be used to track changes over time for two or more related groups that make up one whole category. For example, let's compile the work done during a day into categories, say sleeping, eating, working, and playing. Consider the below code. So this is a classic example for any individual that during this 24 hours days, time that he spends the whole day, how he has utilized his time or where he spent his time these 24 hours. So that is the objective, and we want to depict in the form of a graph, area plot, right? So now again same, import Matplotlib.pie plot as PLT, days 1, 2, 3, 4, 5 days work has been taken into consideration. Then sleeping, you spent 7 hours or 8 hours or 6 hours, 11 hours, one of them. These are for different days. Then similarly eating, 2, 3, 4, 3, 2. This is for the entire day. So that is out of 24 hours, you have spent 2 hours in eating on the first day, then 3 hours on second day, then 4 hours, then 3 hours, then 2 hours, like that. Then you're working, you spent 7 hours, 8 hours, 7, 2, and 2 again. Playing, 8, 5, 7, 8, 13. So that is how your entire day, work has been, or time has been spent during the 24 hours in different days. Then PLT.plot, again, square bracket, color M, label sleeping, line width is equal to 5. Then next is PLT plot, color is equal to C, label is equal to eating, and line width is equal to 5. Then next is color is equal to R, label is equal to working, line width is 5. And then color is equal to K, label is equal to playing, and line width is equal to 5. So all this same code, only thing that you have to repeat to depict it for different colors, your timing. And then PLT stack plot, days, sleeping, eating, working, playing, colors, MCRK, whatever we have mentioned there in the code, the same thing has been mentioned here also in this. And then you are just going to print among the final codes, that is PLT.x label X, PLT.y label Y, PLT title stack plot, PLT legend, and then PLT show. So once you execute this code, you will see that you will get a graph like this, which is an area plot. So you can see in the above image, we have time spent based on the categories. Therefore, area plot or stack plot is used to show trends over time among different attributes, right? So all these 1, 2, 3, 4 colors, you can see that you have spent in sleeping, eating, working, playing. This is the trend that you have for the 5 days, right? So this is how you can present. This is of course a very simple example, but definitely in your organization or wherever you are working, you can see that you can always get a graph like this, which is very, very useful. Then pie chart. Now the same chart which you have seen in the form of an area plot, that can also be depicted in the form of a pie chart. Pie chart, you understand, is circular, and it refers to a circular graph which is broken down into segments, that is slices of pie. It is basically used to show the percentage of proportional data where each slice of pie represents a category. Let's have a look at the below example. Import Matplotlib Pie Plot, days 1, 2, 3, 4, 5. Again same, sleeping, eating, working, playing, and you have got a Slices are 7 to 13. Now these are the slices also you want, right? Then activities, okay, again same, sleeping, eating, working, playing. Columns CMRB, that's again the colors that you want, colors. And then again this code plt.py, slices, labels is equal to activities, colors is equal to calls, strangle is start angle is equal to 90, then shadow is equal to true, explode is 0, 0, 1, 0, comma 0.1, 0, comma 0. Auto percentage, auto PCT, that is automatically you will get the percentage also. That is why you have to write this code for that. And then PLT title, pie plot, and PLT show. Again simple code, whatever you want you have to put in the code, and you will see that when on execution you will get a outcome like that, the way you want it. So you can see a slice has been created for eating and working, and the rest of the activities that you have done, they are appearing in a circle. So in the above pie chart, we have divided the circle into 4 sectors or slices, which represents the respective category: playing, sleeping, eating, and working, along with the percentage they hold. Now if you have noticed, these slices adds up to 24 hours, but the calculation of pie slices is done automatically, right? So automatically it will create the percentage for each of the activities. In this way, pie charts are really useful, as you don't have to be one who calculate the percentage of the slice of the pie. So that is how all these, so that is why the Python has a tremendous power. Just by writing very small codes, you can get all such beautiful graphs and plots, etc. Now multiple plots, as we have seen, multiple types of plots in Python Matplotlib are available, such as bar plot, scatter plot, pie plot, area plot, etc. Now let's see how to handle multiple plots. Now for this we need to import NumPy module, and let us see with an example now. So import NumPy as NP, import Matplotlib Pie Plot as PLT, def ft, return npx exp minus t np dot cos 2 into np dot pi. Don't go by this code, because right now we are focusing on the plots or graphs. So coding you have to learn and you have to practice it. Then T1 is equal to NP, arrange 0.0, 5.0, 0.1, T2, NP, again NumPy array, arrange 0.0, 5.0, 0.02. Then PLT subplot 221, PLT plot T1, FT1, BO T2, FT2, PLT subplot 222, PLT plot T2 NP cos 2 into NP pi into T2, and PLT dot show. So if you have to write this, and you can see that what is the kind of graph that you are going to get, you can come back, practice this, go through this coding, and then you can see that ultimately you get a code like this. Now the code is pretty much similar to the previous examples that you have seen, but there is one new concept here, is this subplot. Now subplot, if you see, we have mentioned somewhere, if you see the 4th line, plt dot subplot 221. Now that is the purpose, because you are creating a subplot, so that is why you are you have given, and that is very useful. So the code is pretty much similar to the previous examples, but you have seen there is one new concept, that is subplot, and this subplot command specifies num row, right? Num row, num column, fig num, which ranges from 1 to num rows, num columns. So the same thing is mentioned here in this also. Like here, if you see, all these things are, they're like 0.0, 5.0, 0. These are all num rows and num columns, and that is where you are getting this kind of a variation in the graph. The commas in this command are optional if num rows into num columns is less than 10. So subplot 221 is identical to subplot 2 2.1. Therefore, subplot helps us plot multiple graphs in which you can define it by aligning vertically or horizontally. In the above example, we have aligned it horizontally, right? You can align it vertically or horizontally, but here, because we wanted it horizontally, so we have aligned it horizontally, right? So this is the way you can create these kinds of plots if required. Of course, normally these kinds of plots are not very common, but yes, if you need it, you can definitely go for it. So that is how you can create a variety of plots, and more plots you can learn when you will go to the seaborne or maybe heat map. You can see that you can learn other types of plots also. So this completes your Matplotlib. Thank you.